translate expressions. We have done this in fifth grade. Yep. The only difference is now they are certainly more detailed than what we've written out in the past here. We're going to introduce at least two new terms. Maybe you've heard them before. When brackets are done. Our objective here is to, again, rewrite things. They'll give it to us in words. We write what it is. Numerical, algebraic expressions. We covered that at the end of chapter 3, didn't we? I believe so. Numerical, right, we did. So what's the difference? This is from 310, by the way, at the moment. What's the difference between a numerical expression and an algebraic expression? George.
Numerical expression has only numbers, and the algebraic expression has letters.
Right. Specifically, the algebraic has a variable somewhere in there. Variable is a letter that represents an unknown value. So 16, that would be an algebraic expression. Number 13, that would be a numerical expression. What would 14 be? Algebraic.
Yeah.
So, got an end there. So, anytime a variable is in play, numerical, algebraic, 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 algebraic. So, anytime there's a variable involved, it's algebra. So, expressions. What's the difference between an expression and an equation? Besides George. Noah.
An expression doesn't have equal signs, and an equation has equal signs.
That's exactly correct. Yep, the equal sign. So, since we're just dealing with expressions, there's no equal signs. You do not need to solve anything today. We're not solving this. There's no solving today. Okay, no math at all today, except for maybe the 15 and 16. They say write the expression, then it says then compute if possible.
It's not possible.
Well, one of them it is. So one it is, one it's not. So you'll do a grand total of one actual math problem today. All right. With, adding, subtracting. So this stuff here, that's not the objective. We know there's no equal sign, so therefore we're not solving, we're not simplifying. All we're doing is writing out what it is. So this is what it looks like in words. This is what it looks like in this way. When it looks this way, you write it out with all these words here. If there's all these words, you make it with variables and numbers. Got it? Just that easy. They give a number of examples here, and we're going to have to definitely talk about these brackets a bit here, because the book does us a huge disservice here. So that means we got to talk about this scenario here. So a lot of these, keep in mind there is a number of ways you can say different things. Again, we covered this concept back here, remember, when we wrote all this stuff out with words and vice versa. Yes, we agreed sometimes things can be stated differently. Like adding could be 36 plus 19. The sum of 36 and 19 added to 36. 36 increased by 19. All of these are telling me the same thing. It's just I've said them all differently, but in the end, they're all the same thing. So you'll get a lot of that. They'll ask you different things in different ways that are the same thing to an extent. Try not to overcomplicate it. So I want to look at this one here, the first one. And I see how the book did it, but we need to understand something here going forward. This is important. So how we write this out here with words here, the way the book does it, they write it like this. 2 plus 3, comma, times 4. Now, only in the 6th grade book do they do it this way, and they don't even do it the whole year. The thing I'm not happy about is this right here, this thing right here, because it really makes things difficult. This is not normally how you would represent this. And none of the other 7th grade book, the 8th grade book, how anybody I know does math does not write this way. Now, they'll write a few things this way with this weird comma thing. Well, they don't have too much here. But the comma here is basically like a 2 plus 3. It's like a then type button times 4. And this is what I tell all the other kids, and this is more relevant, and this is really how it should be. When you see brackets around, right, and we talked about a little bit before, the brackets are almost always going to be around an addition or subtraction problem, right? Addition, subtraction, addition. That's all of them that I see. So instead of this comma here, whenever you see brackets, that implies that you are doing an addition or subtraction problem first, right? Like the money one that we had, that was the 8 weeks, and then the 15 from his job, and then the 5 from his dad, right? And then we talked about basically this is just 8 times 20, right? But then we talked about, well, how it's not really 8 times 20. When you solve it, it's 8 times 20. But what is the scenario? Well, it's 15 plus 5 times 8, right? So we have to do our adding first. Basically, I'm multiplying 8 times the answer to this addition problem, whatever the answer is, right? What do we call the answer to an addition problem? The sum. And what do we call the answer to a subtraction problem? Difference. So, and here's the $1 million statement. Whenever you see brackets, and we're doing this writing, talking type exercise, these are the words you need to use. Sum or difference. In 7th grade, and by 7th grade, we have totally forgotten about the commas, because I told you later on in the year they get rid of them, rightfully so. They're gone, and by the time the 7th grade rolls around, we've already done this type of lesson 3 times this year in 7th grade. But the commas, it's by the first day of 7th grade, you don't even know they exist. You're fully wired to say the sum or difference. So when I see this here, and how do I say this here, I'm saying you got to use the word sum or difference. I'm saying the sum of 2 and 3 times 4. Because when I say the word sum, I'm implying the answer to an addition problem. And when I have brackets, I need to do addition or subtraction first. So basically, I need the answer to my addition problem times 4. Or the sum times 4. So if I was writing this out, I would, and again, in 7th grade, if you see brackets and don't have this word or this word, you get one of these. That means wrong. You got it wrong. If you don't use the word sum or difference. So they do it with these commas here. They do use some and difference, like 11 here. They use the word sum. Thank you. And this is just how they'll write it in all future lessons here. So when we see these commas, though, like here, I guess kind of here too, but we're already doing multiplying before subtraction anyway. Same thing here. That could imply brackets. So I would say this as the sum of 2 and 3 times 4 is how I would say it. Whenever I see brackets, I use the word sum or difference. If I see brackets, I'm writing it out, or then I make sure I use parentheses when I'm writing it out. If you can remember that and handle that part here, then the rest of it is just matching up things you've already done. Subtract this, multiply that type stuff. But trying to get around this part now here with these brackets and the comma versus word difference here is probably the most challenging part. Usually sixth graders get it eventually, before too long. So let's do some together here. Starting on page 124. Huh?
For the test, will commas matter?
I will accept your commas if they are used appropriately and in the right spot.
But what if there's like no commas? Will it?
Some of them there's not supposed to be a comma.
Yeah, but
So
what,
Yeah.
I would avoid usage of the comma if you all can, because again, it's just before this year is over, the comma won't be a part of, and it's not a part of normally how this is done. It's not a part of the seventh grade book. It's just not. There's no. It's a disservice that they wrote this lesson this way. Is what I'm trying to tell you. But whatever you do, however you write, I would try and shift to just using these words and understand the connection between brackets and these two words both ways. If I see these words and I'm writing it out, I'm using brackets. If I see brackets like this and I'm writing it out, I'm using one of these two words. It just depends if it's adding or subtracting. All right, number 1. It says, and you guys try writing it out. You don't have to write all this out. Just write the answer. 8 divided by 4 plus 11. How do I write that? Again, don't need to solve. 8, and again, you got book. Great. You can see the book yourself. So this one, I'm thinking 8 divided by 4 plus 11. That's what it says there. What do we think?
and divide it in a, like in word.
It's already in words.
Or we write it like 6 through 12, like that.
Looking at it says write a numerical expression. This is a numerical expression. It has numbers and order of operation symbols.
Oh, wait.
I'm turning a word phrase into a numerical expression.
Oh.
Anybody write it differently than this? George.
I did the 8 and like a fraction.
You did it like this?
Yeah.
Okay. Anybody else?
I just did the 8.
So then it says then compute. What do I get for an answer?
13.
13. So I guess I didn't see the then compute part. I guess in your homework, you only have to compute the 1, like I said. So. Right, so both of these are correct. If I'm just writing out the expression, I would look for one of these two things. Number 2, 9 minus 6 multiplied by 7. So 9 minus 6 multiplied by 7. Anybody disagree? George?
The brackets in between 9 and 6.
Right. I gotta have, otherwise I have 9 minus 42. That would be a negative 35, by the way. We haven't even talked about negative numbers yet. So that would make no sense at all. 9 minus 4, so that would probably be a red flag that something's wrong. But yeah, 9 minus 6, then multiplied by 7 is how they do it here. So what's the answer this time?
21.
21. So must have brackets here. Without the brackets, you get a whole different answer. I get negative 35. That's not the right answer. The answer is 21. I only get 21 if I do this subtraction first. Man, these. Try number 4. See if you can get the answer to it too. write it out, and solve it. Anybody think they were able to write it out? I've heard from you recently. Who haven't I heard from? Have I heard from you or you?
She said 21 for number 2. Yeah, but that was the
What did you say for number 2?
I didn't say anything.
All right. Well, I better hear from Stella. Okay. So how would I write this?
I wrote it 68 minus 20 in bracket, and then divided by 12.
That's exactly correct. You could have did it this way. You could have did it this way if you wanted. Remember this type of scenario from yesterday when we talked about it with the PEMDAS stuff, how the division could. Again, look at the book problems they had us do, and then look at your homework they had you do after this. It's like so weird, isn't it? Like, do this, and now here's your homework, and it's like, wait a second here.
Okay, I think I've given them enough hard.
They couldn't even give you a bracket. They had decimals all in here, and I mean, fail. Right, so 68, 48 divided by 12, final answer should be 4. But once again, brackets absolutely required here. Without brackets, the other thing I wanted to make sure, 20 subtracted from 68. That is this, 20 subtracted from. What am I subtracting 20 from? 20 subtracted from. I am subtracting 20. That's the first thing I wrote. But what am I subtracting it from? 68. So it's a little easier with how you're solving it. I mean, but if negative numbers were all that, 7th graders, could I see this type of thing written for that thing? Yeah, certainly it's in the wheelhouse, but that would be, of course, very, 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 very wrong. Very wrong. Let's do some algebraic ones then. All right, so basically the same deal. This time we have a variable. So a lot of them they use a number. Number 7, they say cost of a card. We don't know what that is. That's what our variable is. The rest of them, a number, a number, a number. You can use n or whatever you want. I don't care. So I suppose I should actually tell you which ones to do. Huh? Try number 9. $11 and $12. I picked the 3 that don't have commas. So there you go. Use the real words like they should. Saved us the suffering of 7, 8, and 10. I can't guarantee the quiz won't have a comma or test on it, though, just because be fair to the book. So I heard from Stella. I guess I'll leave Stella. Otherwise, I should pull George out, too. And then maybe I could pull Noah out. So all algebraic, impossible to solve, not the objective. Alright. Number 9. You'll have to kind of walk me out there. Alright, Noah, how would I write number 9?
So, would number 9 be, would be, 100, 100 minus n times 3, and then there's parentheses in, or around 9 times 3.
N times 3?
Yeah.
Like that?
Yeah.
Okay. Anybody else? Stella?
I did n, I did n with a 3 exponent thingy minus 100.
Like that?
Yeah.
Oh, yes.
Uh-huh. Anybody else? George?
100 minus n cubed.
You guys are flowing the responses here. Anybody else? I would hate to. Nobody?
No, actually, Stella did. Oh, wait, no, I didn't like.
I'm open-minded here. If anybody else wants to volunteer an answer. I've already heard from some of you.
I
Ella?
have a theory.
100 minus n times 3.
Well, that's the same thing as this guy told me here, so it's still the same, still wrong. Roland?
N times 3 minus 100 with parentheses around 100. Or wait. No, just that.
Ding, 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 ding. First of all, 100 less than implies I'm subtracting 100 from something. 100 less than. I'm subtracting 100. So this one, and this one were, you didn't even have that right. But then what am I subtracting 100 from? A number tripled. That's times 3. A number, this is a number cubed. This, and I would probably write it this way, n times 3, most efficient way would be this. But would I accept that? Yeah, definitely, because this, they're the same thing here. But this is tripled is times 3. Cubed is to the 3rd power. And again, if anything, it's good we had that. So doubled is times 2. Squared is to the 2nd power. Tripled is times 3. Cubed is to the 3rd power. So, but this or this are correct. Subtracting 100, multiplying times 3. No brackets necessary for this one because there's no order of operation confusion. I multiply before I subtract anyway. If I would put brackets, it would be here. But the brackets are pointless because I'm already going to do this anyway, right? Like, duh, I'm already was going to do that anyway. Why did? It's like overkill. I don't really need them. The brackets are for adding and subtracting to bump them ahead of multiplying and dividing. Number 12 or number 11. Lauren.
I got 98 plus a in brackets.
This is in brackets.
Yep. Plus 1 and 3 times.
At some point it said 98 times.
Oh. Then times a no brackets.
So times a, no brackets now. George?
So 98 times bracket n plus 1 and 3 bracket.
That's what I got. That's what I got.
Oh.
That's exactly correct.
That's what I got.
What do you know about that?
So basically I'm multiplying two things, 98 times a sum. Well, the sum is the answer to an addition problem. What am I adding? A number and 1 3/10. I need to add that first because whatever that answer is, then I'm gonna multiply it times 98. So this is exactly correct. 98 times the sum, need brackets whenever I see the word sum or difference, the answer to an addition problem. Again, can't actually solve it right now. No information is provided about what that number is. Not the point of the exercise, though. Number 12. Good to those that got it. Number 12. Stella.
Okay, I did n squared plus
Which it should be
7
there.
minus 5.9 and 7 minus 5.9 is in brackets.
Like that.
Yeah.
George?
Wait, didn't it say the quotient?
Quotient. So
Yeah, I did that.
maybe you just rewrote it. There should be a
Yeah, that's what I did.
division symbol should be there, not
Yeah, that's
addition.
what
Ella?
N squared divided by 5.9 minus 7, which is 5.9 minus 7 is in brackets.
You just have, this is, the order is wrong there. The difference of subtracting 5.9 from 7 is what they're saying. So this is correct. You could have written it this way as well. I doubt anybody did, but you could.
I did that.
George did. Actually, I believe you. George, you have had a propensity to write things this way.
No, I wrote
And
both ways. I did.
Truth
that
be
way
told,
and or.
more things will shift this way than the other here. Again, the word things here. Damien, go away. I don't need you in here. Get out of here. These here, I would try and keep it as simple as possible. So for 13 here, again, it's kind of weird how they do it there. I would say 56 plus 4 1/10 times 2 5/10. There's no order of operation confusion here. How would you say 14?
-8.
I love it. Anybody else? No order of operation confusion. 15. That's Michaela. Roland.
6 into a number plus 10.
What?
6 into a number. A number into 6 plus 10.
Right. A number into 6. Plus 10, that's fine. I'd probably say just a number divided by 6 plus 10. That's good. 16. Ella.
A number squared subtracted by a sum of a number.
Yeah, this one's really hard. That's really good.
Can I try?
She pretty much got it, but all right, Roland, what do you got?
The difference of two numbers and a number squared.
No, difference is okay, but that's not where the brackets reside. Let me just, I don't even know where the Stella stick is. The Stella stick is just gone.
We're just doing random.
Well, I guess George. I don't even have the. Oh, it's a high. Okay,
Alright,
George. I
a
couldn't
number squared minus the sum of a number and a number.